Okay, async await. This is one of the most exciting features that developers have been waiting for. It is a way to write functions that contain promise-oriented or asynchronous code that looks synchronous. So, what do I mean by this? Well, when we think back on our last lesson on promises and fetch, we know that with our fetch call, if we were to write it with the style of promises, that we would fetch our users, and then we would get the response. We would call response.json, which gives us back a promise, which we then pass to our then, which now finally has our array of users. We would then cast our first user constant with the first user object in our array. We log it out so we see what our first user looks like. And then we return fetch to this link, right, which has posts, except we set a URL parameter where the user ID is equal to our first user.id. So we want all of the posts related to our first user. And then we get back a response. We convert it to JSON again, right? Which then we pass through into our next then, and then we console log the final posts. So it's a lot of things happening here. And what this actually looks like for us, if we copy this, we go back to our browser, and then we paste this in, we see that what we get is our first user, which gets logged, and then we log our final posts, right? So this is pretty much stuff that we're familiar with when it came down to writing our code. Now, if we wanted to do this in async await, the way that we would do it is we would cast a function called myAsync function, right? And we make it an async function by writing the async keyword. And then we essentially write a function anyway after, right? So by saying async and then our function declaration, JavaScript knows that we want to make an async function. Now, by using this async keyword, within our async function, we're now suddenly allowed to use the await keyword. And what await does is it pauses the function's execution until what is being awaited is completed and comes back with a value. So what do I mean by this? Well, if we were to say await and then we want to fetch this value that we had above here, any code down here would wait until this fetch comes back with a value. And the way that we would use that value is we're actually able to cast it to a constant because that's what await does for us. Await takes that resolve promise value and then sets it to the constant that we declare it equal to. So if I say, this is my user's response, right? Now I have that same response object cast to this const user. And any code following was waiting until this fetch completed. Now we do this again with our actual users, but we have to await for our user's response to be converted to JSON, because this is also an asynchronous method of converting it to JSON. So this method returns as a promise, right, which resolves with the final JSON value of our users, which we cast to our const users. And now we can say const first user equals users at 0, right? Let's console log this first user as well. Actually, let's just change it up, and instead of our first user, we'll say second user, right? So we'll use our second user. And then we want our posts response equals to our fetch, right? Like so. Except we want to use our new second user. But our fetch, we want to await for it. And then we want our posts to be await of our posts response.json. And now finally, we console log our posts. By doing this, this code reads more like synchronous code because we see, oh, there's just a variable declaration. It's just waiting for our asynchronous requests to complete, and then they cast their values, right? Their resolve promise values to our consts respectively. So as we see, this actually looks a lot like normal synchronous code that we would write. Now let's see if this works. So let's copy this. And then let's just paste it in. And let's call my async function. And we see there's our second user, and there's our posts related to our second user. So this is what async await allows us to do. So both methods are valid when it comes to tackling this kind of asynchronous problem. Specifically, what we were trying to solve was that we had code that was dependent on an asynchronous code above it, right, to complete before it could actually run. What do I mean? Well, we were not able to fetch our second user's posts without having a second user in the first place. And getting our second user was dependent on fetching a list of users first, right? This code is asynchronous. We did not know when that would complete. This could have taken half a second or it could have taken 3 seconds, depending on multiple factors. Now, both are valid because this structure of promise chaining is just like await. Each then is waiting for the previous one's then callback to complete. So this return of this promise, this whole chain is waiting for this then block to complete and this fetch to complete, resolve or reject. But with async await, we're able to write it in such a way that it resembles more of the synchronous code that we're used to writing, because we're able to cast these constants, right, which are just equal to awaited values of these function method calls. So in a way, you can do both. It doesn't matter. It's just which one is more readable, which one is more reusable. Now, one thing I have not yet talked about with async await is error handling. We know with our promise chain that if we do a .catch right here, we are able to handle our errors. If an error occurs at any of these thens, this catch will catch the error for all of them, right? If any of these reject, this catch will be there for it. How do we do that with an async await function? Well, what we have to do is use a JavaScript try catch block. And what that looks like is just this. We have a try keyword with a block of code, and then there's a catch keyword with our error, and then a second block. So we put the code that we want to run inside of our try block. And then in the catch, if any error occurs in this try block, any promises reject, any of the stuff with our fetch that fails, right? Then this catch code will run, and that error is what will get passed in here. So if we wanted to console log, there was an error, we are able to handle our errors this way. So if we were to try this, and let's say we just mistype this string, right? Now if I call my function, we will see that our error got thrown. So while this code ran, it's because up until this point, this code was all valid. But the moment that this error occurred at this fetch, it threw the error, it paused the execution, right? It doesn't keep going, and then it just throws. So this is how async await works. And just like that, you now know the 2 ways of handling asynchronous events.